So problem 5, this is set properties. So consider the following statements. If they're true, give an example. And so the question is, does it matter how I look at intersection? And if you think about the Venn diagram of our set, here's our set A, we've got a set B, and we've got a set C. So if I look at B intersects C, that's going to be all of this over here. And if I intersect that with A, I end up at this point in the middle. If instead I first look at that intersection of A, B, then what I would have gotten is everything polka dotted here. And then I intersect that with C, that's going to be, again, everything in the middle. And so no matter what I do, that works out. And this is a property of sets. And so it says, if I believe it's true, give an example. And so I'm going to claim this is true. And there's my sort of diagram representing it, but I want to give an example. And so with this example, what I can check is that B intersects C is going to be 3 and 4, and A intersect B is equal to just 3. So if I look at the left-hand side of that equation, I have A intersect B intersects C, which is the same as 1, 2, 3, intersect 3, 4. And we see they only intersect at 3. And if we check A intersect B intersect C, that's the same as A intersect B, which is just the 3, intersect C, which is that 3, 4, 5. And again, they only overlap at the 3. And so both of those are equal to the set containing 3. And so it didn't matter how we place the parentheses, we always got back to the same place. And that is not a proof, of course, but it is an example showing that that would be the case. So let's look at the fact that A intersect B is a proper subset of A. So I'm going to say this is false. And that's because I can let B be the empty set. If I take the empty set away from A, I get back to A, and A is not a proper subset of A because A is equal to A. Now, what about A minus B and B minus A? This is a problem. We know this is a problem. This is false. And this is false. Let's let A equal the set 1, 2, 3, and B equal 3, 4, 5. So if I draw this out, we know that there is something in the middle. I've got within our set A, I've got 1, 2, and 3. And within our set B, I have 3, 4, and 5. And so the elements of A minus B are all of those things in A that are not in B. So that's 1 and 2. And B minus A, that's our set, everything that's in B minus that which was in A. And so that's our set 3, 4. So that's a problem. They're not equal, and so this whole thing is false. Okay, how about this? If A is a proper subset of B, B is a proper subset of C, then A is a proper subset of C. And this makes sense. So if A is a proper subset of B, so we've got our set B, and A is inside of it and not equal, and B is a proper subset of C, so it fits inside of it, and there's something out here, we don't know what it is in each case, so some X out here and some Y out here such that they're not equal, then this is going to be true. So I just need to conceive of a set that looks a little bit like this. So I can say A contains a set, is the set containing 1, so there's my 1. B is the set 1, 2. So we see that A is a proper subset of B, and C can be the set 1, 2, 3. Might as well come up with the simplest thing that we can fit. So the 2 would be out here, the 3 would be out here, and it works. So A is a proper subset of B, B is a proper subset of C, and we can see that A, which is equal to the set containing 1, is a proper subset of 1, 2, 3, which is a proper subset, which is equal to C.